what we have here is two cars, M and N, travel towards a junction O on roads which are right angles to one another. Car M is travelling east at 6 meters per second. Car N is travelling north at 8 meters per second. At a certain instance, M is 65 meters away from O. At the same time, N is 20 meters from O. How long does it take N to reach O? How far from O will M be at this time? Find the velocity of M relative to N. Calculate the shortest distance between their cars in their subsequent motion. Okay, so what we're looking at here, guys, is you want to create a junction. The junction will be created like this. Okay, so there's your junction. Now, at the start of the question, M is traveling east, so it's going to be traveling east at 6 ms to the minus 1. N, now, in a certain instance, M is 65 meters from O. Same moment, N is 20 meters from O. Keyword, towards. Okay, what would be wrong if I had it like this? It has to be, N has to be underneath the junction to be going towards it. Okay, so therefore, N is underneath, and N is going 8 meters per second. Okay, now what we know next is how long does it take N to reach O? It's basically a distance over speed question. So what's distance? Distance is 20, and speed is 8. So 20 divided by 8 is 2.5 seconds. Happy enough with that? 2.5 seconds? Okay, now 2.5 seconds. Next thing we got to figure out is how far from O will M be at this time. M is currently 65 meters away. 65 take away, it's going to have 2.5 seconds traveling at 6 meters per second. So it's going to be 65 take away 15 gives us 50. Now, in all these questions, more than likely, the best way to do them is to actually start them off with one of them at the junction. So I can make a new diagram. My new diagram can look like this instead. So instead of the original diagram I had, what I can do this time around is that I can have a car N actually at the junction going up at 8 ms to minus 1, and I can have car M, and that is going to be 50 meters away, and it's going to be traveling at 6 meters per second. Now, what we can do then is we have to next find the velocity of M relative to N. N relative to N, okay? So, what we're going to be looking at here is M is the first letter, N is the second letter. So, which one is stationary? Does anybody tell me? M. Sorry? Oh dear. VMN. So, that means that for all purposes, N is held stationary. You got that? And it's still stuck to the spot now. Okay? So, what is phi M? Phi of M? Anybody?
6i.
6i. Phi of N? Anybody phi N? AJ. Phi MN? 6i minus 8j. Now, what we have now, once again, is we start off with this diagram here. Now, what direction is 6i minus 8j going in? What direction, anybody? East and then south, because it's going 6 across, 8 down. Okay, so 6 across, 8 down. So with that. Now 6 across, 8 down. So here is our initial displacement shown. M is here, N is here, 50 meters apart. N routed to the spot. Their relative velocity to each other is the relative velocity to each other is going south east. This angle here. Okay. Now, what I'm going to do is I'm going to figure out what is this angle. Okay. So what I can figure out from this is that that's 6 across, 8 down. Tan x. What is tan x then? Tan x is what?
Yeah, 8 over 6.
8 over 6. If I do Pythagoras' theorem, guess what I'm going to get? 64 plus 36, 100, root 100, 10. So that means that cos x will be adjacent over opposites, or over hypotenuse, 6 over 10, which is 3 over 5. And sin x is going to be 8 over 10, which is 4 over 5. If you want to deal with angles, you're more than welcome. You could always just tan inverse it. Tan inverse 8 over 6. And then you get a 53.13. Is that right? So it's a 53.13 angle anyway. So 53.13, also known as x. Now, we're going to find the shortest distance between the two of them. Now, if my answer is correct, what does it need to be most definitely less than? It has to be less than 50, doesn't it? Because if it's more than 50, we've gone backwards. They're further away than ever. Okay? So let's see what happens. So this is the subsequent motion of m relative to n. It's coming, and then eventually m is located here relative to n, and then we draw up our perpendicular line, like so. Now, how do I find d, lads? D. Anybody tell me how to find d? That's the 90-degree angle there, by the way. So, 50 is the hypotenuse, and d is the opposite. If it's opposite the angle we're using, it's the opposite. Okay, it's alright. So, sine 53.13 equals d over 50. Bring up the 50. Can anybody tell me what 50 sine 53.13 is? Any idea? So? 40? Just 40?
It's 39.99.
Okay, so if I actually used the ratio, it would have came out exactly. So it's 40. Okay? Oh, sorry, if we used that ratio there, 4 over 5, it would have came out second. So it is 40. D equals 40. So guys, 40 meters, okay? Alright guys, so that's it, 40 meters. Everybody happy with that? Okay, let's try another one. Now this one slightly more difficult than the last one. Why would this one be considered more difficult than the last one? Anybody tell me? Yeah, but the problem is with this one is the angle. You see the angle at the beginning? See, they're not perpendicular to each other. The rows are at different angles to each other. Now this is an example of a 2 part A in Leavenscert. This could easily come up. Okay, so Cars A and B are travelling towards O on these roads at 16 meters per second, and B is at V. Won't even tell me what B is. Okay? If the magnitude of the velocity of A relative to B is 16 meters per second, find the value of V. That's interesting, right? 16 meters per second. Alright, here's what we're going to do. We got to find out what phi A is, and we got to find out what phi B is. Now, anybody tell me what phi B is? That's really easy to get right away. It's minus phi I. Is that right? Going to the left is negative I minus phi I. Right there, okay? So, once that's done, the next thing we're going to do is phi A. Now, what we've got to understand about phi A is phi A comes down at this angle here. This angle it comes down at is angle theta, and it comes down at 16. Now, what we know about angle theta is that it's tan 4 over 3. It's a 4:3 ratio, correct? Now, if I examine tan theta as a triangle on its own, theta is going to be opposite over adjacent is 4 over 3. Do Pythagoras' theorem, that turns out to be 5. Okay? And once you do that, then what we got to figure out is what is cos theta, sin theta, tan theta. Okay? We know now that cos theta is going to be 3 over 5. And we know that sin theta is 4 over 5. Now, using this logic here, is everyone happy with that? I'm just using a triangle for this one here. I'm just figuring out all the sides of a right angle triangle that has theta as an angle. Okay? Now, what I got to do next is I got to figure out what is x and what is y. Now, x, if cos theta equals adjacent over hypotenuse, which is going to be x over 16. Okay? We know cos theta is what? 3 over 5. Therefore, x is going to be 48 divided by 5. Anybody tell me what 48 divided by 5 is? 9.6, is it?
Yeah.
Okay, so that's 9.6. In the same breath, we also have to figure out what is. We also have to figure out what is y value. So to fix the y value up, we just change that to sine. So call that sine theta. Sine theta is y over 16. And then y over 16 has to equal sine theta, which is 4 over 5. So this time it's going to be 4 times 16. 4 times 16 is 64. What's 64 divided by 5? 64 divided by 5? Yeah? What? 12.8. Now, you go, it's diagonal left down. So guys, diagonal left down means a negative j value and a negative I value. So what we're looking at here is we're looking at doing next is we have to find out what phi A is. Phi A therefore is phi A therefore is going to be minus 9.6i minus 12.8j. Now, if I was to give you a velocity, okay, and I was to say, this is a side question now, this has nothing to do with what we've just done, okay? Just trying to explain something. If I told you phi xy was 3i minus 4j, how would you find the magnitude of that? The magnitude means the... Okay, this is basically, you're right, it's a speed that goes diagonal right down. It's going 3 across and 4 down. You just want to find out the hypotenuse, which is the square root of 3 squared plus 4 squared, yeah? So it's what you can basically find it by doing this. The magnitude is 3 squared plus whatever the j value squared is and square root the answer, okay? So what we're going to do now is in this question here we're going to do something very similar to that. First of all, we have to find out what phi b is, okay? Yeah?
What is the magnitude?
So magnitude is basically, if I'm going 3 across, 4 down every second, I'm technically going down 5 meters per second at an angle every second. So if you were to walk 3 steps, 3 meters straight, 4 meters left, it's the same thing as doing 5 meters in a diagonal in the same amount of time.
Yeah,
that's magnitude. Yeah. Okay. So in this question here, then we got to find out what is magnitude. Okay. So the magnitude is, I first have to say, key words are the magnitude of the velocity of A relative to B. That language there tells me I need to use phi b to get any marks on the board. Once again, it's going to be phi a minus phi b, which in this case is going to be it's going to be minus 9.6 I minus 12.8 j, and then it's also going to be minus phi I. Now 9.6 and v are both the I values, so it's going to be v minus 9.6 I, and that's going to be minus 12.8 j. Now I have no idea how big v is, okay? I have no clue what direction it's going in at the moment. But what I can do is I can construct a triangle. Doesn't really, we know it's, it doesn't really matter as such. We can just say, look, it goes 12.8 and it goes v minus 9.6, and we know that the hypotenuse is 16. So what can I do here to figure out v? Anybody want to tell me? Sorry? Do Pythagoras. At the end of Pythagoras, you're going to be left with a quadratic formula. Okay? So what I'm trying to do here is do the quadratic formula here. So we're going to get 16 squared equals 12.8 squared plus phi minus 9.6 squared. 16 squared is 256, is it? Or something bigger than that? No, it's bigger, is it?
2.6.
Oh, 256. 12.8 squared. Yeah, and can you give me 9.6 squared? Twice that is 19.2. 9.6 squared? 92.16. Was it 93?
92.16.
92.16. Now, it's not the nicest phi squared question I've ever had in my life. Okay, it's particularly nasty, to be honest. So I get phi squared minus 19.2v. Can somebody tell me what is 163.84 plus 92.16 and then take away 256?
Zero.
Is it 0? Oh, that's really great. That's actually much better now. So what we're going to have now is we can now solve this. B into v minus 19.2 equals 0. V equals 19.2. We got it. So now we have V. And we're this far along the question. Okay? That's as far as we've gotten so far. Okay? Which isn't great. Now, so 19.2. All that for 19.2. Now, at a given instance, A, oh wait, that's wrong. Here you go again. At a given instance, A is this far away from the junction B, and we have A is 96 meters, B is, what did we say B was again? 38.4, and B is 19.2. Which one's reaching the junction first? B is going 19.2 seconds towards the junction. It's going to reach it in 2 seconds, because if I say when does B reach the junction, when does B reach here, it's distance over time, distance over speed, which is going to be 38.4 divided by 19.2 equals 2 seconds. So in 2 seconds time, B is at the junction. How far is A going to be away at that time? Can you tell me how far A is going to be away? It's going to be 96 meters, take away 2 multiplied by 16, because it travels 2 seconds at 16 meters per second. And what did you say, 54? So 64. 64, yeah? So 64 meters. Okay lads, so 64 meters away. Now, fortunately I have to, it's 64 meters away from the junction. Find the shortest distance between the cars in the subsequent motion. Okay, so I have to go back to VAB. Okay, so what we did earlier, velocity of A relative to B. So I have to go back to VAB. Now, just VAB. So we know that VA is, what did we say VA was again? It was, that was 16. What did we say that down the left was again?
9.8.
Sorry?
12.8 down.
Oh, is it? 12.8 down, yeah. And the other one?
And 9.8. 9.6.
9.6 across. Okay, 9.6 across. We'll just quickly check that. It's no point starting off with figures you're not sure about. So it's going to be 16 multiplied by 3 over 5. 9.6, and the other one 4 over 5. 12.8. Well, good memory. 12.8 and 9.6. Now, what we said, so that was minus 9.6i minus 12.8j. Excuse me. Next one, VB, is minus 19.2i. Now, what we're looking at here is VAB. So VAB therefore was it was 9.6 minus, what's 9.6 plus 19.2, anybody? I think it's plus 9.6, isn't it? So the relative velocity is VA minus VB, which is minus 9.6 minus 12.8. That's I, that's a J, and then minus 19.2. So 19.2 minus 9.6 is another 9.6. 9.6i plus 12.8j. That is the relative velocity. Can anyone in class tell me what direction does this relative velocity actually go in? Huh? northeast. Okay, it's a northeast velocity. Okay? Sorry? It is actually right, it is minus 12.8 J, sorry. So guys, it's minus 12.8 J. You'll actually see in a second that going northeast wouldn't have made any sense whatsoever, because it has to be going closer to it. So that's 9.6 minus 12.8 J. So VAB is 9.6 I minus 12.8 J. Now, what we're looking at here, guys, is okay, which one's held stationary, guys? Which one's held stationary? B. B is held stationary, okay? And relative to B, what we have is so what this changes to is this. B is now held stationary at the B is now held stationary here. 2 seconds into the future, B is now stuck here to the spot. A is coming towards it. A is 64 meters away. We have B is stuck and A is coming towards it. Now, what I need to do is I need to find out some angles belonging to A and B here. So, the angles that we're using here are going to be, it's going to be right and down. So it's going to be going this direction here. So it's going to be going 9.6 across and then going down at 12.8. Will somebody tan inverse 12.8 divided by 9.6 for me? So I want to find out the angle X. So it's tan inverse 12.8 divided by 9.6. Anybody tell me that angle? What is the angle X?
53.13.
Is it? 53.13? Okay. So that's 53.13. Now, it's going in a southeasterly direction, okay? So, if I modify this diagram here to my right, you can see that the velocity of A relative to B is going this direction down here, okay? And at the closest point, this here is going to be at 90 degrees, isn't that correct? 90 degrees. So, relative to B, which is now stuck at the junction, A is travelling down this direction here. Okay? Now what we have to do is we have to zone in on this area here to find out what angle we're dealing with. So what angle are we actually dealing with here? So, yeah. I'll show you now. I have all the information I need here. Now, so, dealing with here, guys, is that would everybody agree that if I drew a line going up here, that is a alternate angle? Yeah? So, this angle here where the 16 comes down this way, this angle here is tan inverse 5 over 3. What did we say tan inverse 5 over 3 was again? Anybody tan inverse 5 over 3 for me? What do we get? 53.13, okay? So that's 53.13. Then, if I draw a cross here, and now I'm really trying to find out this angle here, guys. See that angle there? It's the angle I'm really trying to find out at the moment, okay? So what we know now is that this angle here, if we keep going straight through, our angle downwards was also 53.13. Okay? So what we do is we draw our angle downwards, and that's 53.13. What does that leave for the angle in between? 180 minus 53.13 minus another 53.13. What does that give us? Sorry? 73.74. Now guys, what we're now going to do next is we're going to focus in. Shh. Oh wait. Oh, what did you do that? So, what we're going to do next, guys, is we're going to focus in on this triangle here. Does everybody see the blue triangle here? Stay where you are. Everybody see the blue triangle here? What we're going to do is we're going to focus in on that triangle. That triangle has a 90-degree angle here. This is your closest distance, D. So what you're looking at is this. D is here, and that here is 73.74. That's a right angle, and you knew that it was 64 meters away to begin with. You want to find out the, sorry, that's not D, that's D. You want to find out the opposites. It's opposite over hypotenuse. So sine 73.74 equals D over 64. Multiply 64 by sine 73.74, and what do we get? What's D? 61.44 meters, okay? Now, it says the distance to the nearest meter between the cars 2 seconds before that instant when they're nearest to each other. We already found that out, didn't we? 2 seconds before this, B was at the junction and A was up here, and they were 64 meters apart, okay? So that's that one done. Guys, for your homework,